ground truth loop closure, ground truth edges for loop closure. So as we informed, we start working on automatic loop closure. So we provide tool for annotating ground truth slam loop closure. So we published data here, so you can just go here in Zenodo, and you have data sets. I will choose the smallest one. Okay, so I will download the smallest one. It is downloading, and you can use software from this link 097. So we download this. So we are downloading software and we are downloading dataset. So we have software here, so we will extract here. So our software will be here, and it is this one, multi-view TLS registration step second. So give me a second, I will check if we downloaded everything. Not yet. We have to wait 15 seconds. Okay, so it is almost downloaded. Still not yet downloaded. Be patient, yeah. It's supposed to be downloaded already. Oh, it is downloaded, so let's try to uncompress it. Okay, so we have this folder here and all data is here. So we will open our software. We open the session. And our session is session MLC. It is suffix, I name it manual loop closure. So let's open it and wait a moment. Yeah. So in this dataset we have trajectory and we have loop closures that they are manually labeled, annotated. Yeah? Almost loaded. Please be patient. Okay, it is loaded, so we can see it. We can see from line view. Okay, so it is quite simple dataset. So let's open manual loop closure, and we can see 14 loop closures. So if you manipulate active edge, you can go from one to another, and you can see your data from this is edge that they are. It is composed by two point clouds, and the transformation between them, it is done by me semi-manually, so manually, and then using ICP. Okay, first thing you can do is you can decide, you can extend your data, or you can just leave like this. So, shortly speaking, you can ask, you can query entire data set about your metadata. So if you type print all relative poses in console, then you have all necessary information in the console. So if you mark everything, you save, and then you save it, let's say in txt file. Then you have everything you need for your AI training. So you have source file and target file, and you have relative pose from source to target. So I will try to demonstrate it to you. So shortly speaking, once we have active edge first one, let's save source. So we have source. Let's save target. So I saved point clouds in local coordinate system. Then I can ask about relative pose between source and target, and it is this matrix. And if you go to the edges, it is exactly the same pose. Okay, so you can see here, this is your relative pose. And imagine the situation that you would like to use your AI tool for retrieving this relative pose. So I will demonstrate you with Cloud Compare. So we have Cloud Compare here. And source, we load source, and we change color to the red one. We have target, and we change color of the target to blue one. So we have such a situation. And if we move source with this tool, and we just move it here, but let's observe. Okay. And let's rotate via Z. And let's move again. So it's supposed to be manually aligned, but imagine that your AI is doing that. So if you apply, then your transformation is here. And it is very similar what we have here. So shortly speaking, what we did, we use our tool to export all information to console, that this information can be used for your AI training. So you have source and target. Data are stored in our folder, so you can find data here. This is data scan Leo. Okay, and you have also relative pose. So scan is you have source here, you have target here, and relative pose between them here. Thank you for watching video. If you have any question about this video, or if you have any problems with this tool, please let me know. Thank you.